Okay, thank you very much for your introduction. I would like to talk about urban safety evaluation and ESG investment. And my subtitle is Market Creation using a high resolution simulation technique for a whole city. I'm Atsushi Izuka, Kobe University. The background of my presentation is recent DX digital transformation. It is said that the DX will revolutionize our society. The core of this DX is thought to be the urban digital twin. This is a technology to create a city that is a mirror image of a real city in the virtual space of a computer. We can see how the city in the virtual space behaves, how its urban function change or are lost, and how the city is affected by external impact, such as natural disasters. Furthermore, we are trying to predict in advance how people in the city will behave. Building a digital twin of a city requires extracting information about the elements that make up the city from the big data in the cloud. The amount of information required is so great that this task must be done automatically. Appropriate interpretation of this information is made to construct a digital twin in the virtual space of the computer. This process also must be highly automated. Once an urban digital twin is constructed, it can be visualized from a bird's eye view. This is where technological innovation comes in. It simulates how a city behaves when a digital twin in the virtual space is subjected to an external shock, such as a natural disaster. To be able to simulate a city, the characteristics of its component must be inputted. Here, technological innovation is needed too. The technology up to this point has in fact already been developed and is at the stage of social implementation. Today's talk is about using this technology to greatly advance disaster prevention and mitigation. The data required for urban digital twin is diverse. The necessary information is automatically read from these data to construct the urban digital twin. In the case of RIKEN's simulation of the entire city of Kobe, data from more than 10,000 ground borings, 220,000 buildings, and a network of buried water and sewage pipes were loaded. Earthquake, tsunami, heavy rain, and flood disasters are also the people evacuation are performed on this urban digital twin. Such a simulation forecasting will help that the public can use it to improve the efficiency of the public administration and to promote efficient national resilience. And the private sector can use it. Rationalization of design and cost reduction through the simulations integration, improvement of international competitiveness, attraction of infrastructure investment, and the creation of a financial market and promotion of national resilience through private investment. The wide variety of infrastructure data, land data, the data on economic activities, data on natural phenomena, and others required for the urban digital twin is being compiled into an infrastructure data platform. This is a project being undertaken by the Ministry of Land Infrastructure, Transport, and Tourism. Access to this infrastructure data platform will facilitate the construction of an urban digital twin. There are three key data-driven technologies. The first is a data linkage technology that connects various types of data. The second is automatic creation of a metadata technology that add metadata necessary for the finding the necessary data. And the third is a data integration technology. These technologies are being developed and implemented in society. As for the social implementation of the above technologies, we have established the Technical Research Association since 2019 to develop technologies for simulating whole cities and to promote the social implementation of these technologies into the private sectors. Specifically, the activity are as follows. Development technologies necessary for social implementation, techniques, API, and so on for cooperation with National Land Transport Data Platform. The techniques for automatic creation of urban models necessary for various forecast simulations, data conversion and data integration technologies that can be applied to BIM and SIM. Improvement of skill of civil engineers is also important. Here is a little more about the Technical Research Association. The system finds necessary data from a wide variety of infrastructure data, automatically read the necessary information from the data, and construct a digital twin in a virtual space. This basic technology has been developed and evolved at the Earthquake Research Institute of the University of Tokyo and subsequently at the RIKEN. Simulation technique has also been developed to predict the behavior of a city when subjected to external actions such as earthquake, tsunami, and heavy rain, and flood, and so on. The Technical Research Association was established to implement these technologies as a whole in society. Now, 9 construction companies, 5 consultant firms, and 3 IT vendors, 1 financial bank are joining the association. And researchers from Kobe University and the University of Tokyo and research institutes such as RIKEN, JASIC, and JAMSTEC are also participating. By promoting social implementation in the private sector, we hope to support the smart city concept being promoted by the government. And furthermore, active contribution to the realization of DX implementation in finance and logistics and the creation of new markets will emerge from this. Here are some examples of technologies that have been developed and are being implemented in the society. This is a map of an area of Kobe, which measures 3.4 kilometer east to west and 4.7 north to south. There are approximately 150 ground borings in this area. The geotechnical model is automatically constructed from these boring data. This ground model can easily to be subjected to finite element simulation, and the three-dimensional liquefaction analysis is being performed. Below, a liquefaction analysis is being conducted at a 5.5 kilometer east to west, and 4 kilometer north to south area in Tokyo, using a 3D ground model automatically generated from boring data. Since this is a demonstration of a technological development, we are dealing with a relatively small area, but with sufficient computer capacity, the model area can be easily to be expanded as needed. Now let us summarize the features of a whole city simulations. Various simulation can be performed on the urban digital twin. Here, many scenarios, a wide range of possibilities, scenarios can be covered. This means drastically reducing the number of unexpected events. Second, quantification. Quantification of risk can be made in a comprehensive, comparative and quantitative manner. This means we can share the risk among people. And the third one, and wide area and high resolution. This enables comparison by space and time of our wide area. This means we can evaluate the risk. Last one is integrated visualization. This is a very important. Various information can be presented in the integrated manner. This encourages mutual consensus building. The our technological background is now progress in the use of cloud computing for supercomputers. The practical use of large-scale parallel computing using, for example, the GPU, and evolution from the K computer to Fugaku computer in RIKEN. And various numerical simulation techniques can be employed. We have many good simulation techniques, then we can use these techniques in our simulation, in this kind of simulation, in the digital twin. And also, progress in technology for automatic reading of various digital documents and drawings and the automatic construction of an urban model is drastic. Data conversion technology, application linkage technology, and visualization technology, they are the very sophisticated and improve our activity. Thus, whole city simulation would reveal change in the functioning of a region, the behavior of the ground, infrastructure and building that make up the region, and the combined movement of people and object in an integrated manner. Namely, this means realization of a quantification and visualization of disaster risks and their temporal and spatial changes through the wide area with high resolution and multiple scenarios. Therefore, this will help us to identify the vulnerabilities, weak point of our society in the event of a disaster, and to materialize the associated risks, which will help us to prepare for disasters and strengthen the resilience of our land. In other words, it will be useful for minimizing risks in advance and speeding up recovery process from disasters. This will, I believe, represent a paradigm shift in the disaster prevention and mitigation. Now let us dig deeper into that paradigm shift and consider the resilience enhancement by the private sector. In recent years, corporate investors have begun to place greater emphasis and interest in the non-financial information about individual companies, which is ESG investment, which consists of E of environment, S of society, and G of governance. We shall discuss a little bit a way to incorporate the disaster risk management and mitigation into this ESG investment. If risks are embodied through the whole city simulation technology, corporate activity to mitigate those risks would be suitable for the ESG investment. If so, the investment and activities of each company in disaster prevention and mitigation could enhance the corporate value of the company, and thus it would result in the enhancement of the resilience of our nation. The whole city simulation technologies reveals the disaster risk of the company. The company invests in mitigating the risk. Of course, the investment will be reflected in the BCP of BCP of the company. This investment is evaluated as an ESG index. This is in turn encourage investors to invest in the company. This will lead to an increase in corporate value of the company. If such a cycle occurs, it will in turn lead to the strengthening of a national resilience by the private sectors, such as private companies. This means that disaster prevention and mitigation is no longer a maintenance cost to be taken by the government, but an investment target for the private sectors in ordinary peacetime. This is a substance. This is a substance of the paradigm shift in disaster prevention and mitigation. Let me summarize at the end. On one hand, institutional investors such as GPIF, which is the biggest investors in our country, emphasize non-financial information such as ESG. And the companies try to achieve ESG indicators to increase their corporate value. The sustainable development of a company requires result in non-financial areas. On the other hand, infrastructure data platforms are being developed. The information necessary for the urban digital twin can be obtained. Urban digital twin can be realized throughout Japan. At the same time, large-scale data transformation and data integration can be realized. The various types of predictive simulations can be performed. This makes it possible to materialize and quantify various risks. Combine these two, it is possible to present quantitative evidence for disaster risk. Therefore, for the company, investment in disaster prevention and mitigation leads to a reduction in the risks that the company faced, and as a result, increase the value of the company. At the same time, it is also strengthen the resilience of our natural land, our natural land. In other words, ordinary activities based on the economic principles by companies lead to the enhancement of national land resilience and the progress of disaster prevention and disaster mitigation. Can we draw this kind of picture? This is my question. That's all. Thank you very much for your attention.